everyone. Very good afternoon. Welcome to today's class, today's Unit 1 class. I hope all of you are keeping fine, doing good. Students online, I hope you all have your notes with you all. You all are with me. I hope you'll have a writing book also. We might have a few diagrams to draw today. Okay. So everybody, a reminder, we are in topic 12 right now. And today we should be finishing part 2. We should be coming to an end with part 2 today. And then guys, very soon we'll be having it. I'll give you all the exact date. Okay. I'm not still decided whether to have it next week or the week thereafter. What was I going to tell you all? To have an online quiz with you all, whether to have it next week or the week thereafter, because in topic 2 there is still a lot more to go. Okay, there is still a lot more to go, so I haven't decided whether to do it next week or the week thereafter. I'll keep you all informed, but keep in mind there is an online quiz coming up very soon. Okay, and most probably end of third week of October we will be finishing topic 12, so then we can have an exam on topic what? Topic 1 and topic 2 together. We can have a writing exam. Okay, most probably somewhere around maybe the third week of October. Okay, right, everybody, let's get moving. Let's continue from where we have stopped. Now, guys, girls, all of y'all, in topic 2, part 2, we only spoke about one concept. We were talking about two network models. Okay, boys, are you all with me? Do you have your notes and all with you? Okay, we're talking about network models, and we spoke about a network model known as client to server or client server network model. Okay. What is so special about this model? There are two types, client to server and peer to peer. In client to server, you have something managing the whole network, which was known as your what do you call the computer that manages the whole network? The server. You have an extremely powerful computer, a supercomputer, a mainframe computer managing the entire network, which is what we were calling client to server. Okay. Any real life examples you guys can give me for client to server? Any real life examples of where your device was a client connected to a server? No examples? Come on. Guys, any real life examples you can give me of where your device was a client connected to a server? Instagram, sorry? Social media, Instagram, when you're checking your email, when you're trying to book a taxi, when you open up Uber, is it clear? When you use when you basically use any online service, you are connecting to a server, and that server is sharing a platform with you. Is it clear? Those are the resources that the server is sharing with you. Okay, that's what we were calling client to server network. Okay, right. Then guys, under client to server, we had different servers. Sometimes servers are dedicated to carry out certain functions. So we spoke about how you can have a server called a file server. Its job is simply to hold user files. That's all it does. Storing of user files. Did I show you all any real life example? I didn't show, right? So everyone look here. I'm going to go into my cloud storage. Everyone look over here. If I were to go into my cloud storage right now. Right now I'm on my cloud storage. So for sure, I would be on OneDrive's file server where I can see all my files. Everybody okay with this? This server computer is solely responsible for holding all my files. Let's say, for example, if I were to open up a particular file, anyone knows which server I would be on right now? Let's say I were to open up this Word document. When I open up this Word document, most probably I'm put onto a different server known as an application server. Everybody okay with this? Most probably now I'm on my application server. Oh. Okay, let's go again. Everybody, guys, girls, let's go again. Right now I'm on my file server where I can see all my files on the cloud. So right now I'm on my file server. Once I open up this application, I would be on my file application server. I messed up the words, didn't I? Right now, file server, where I can see all my files. When I open up a particular file, an application opens up now. So now I am on what we call an application server. Everybody okay with this? When I go to this website, when I come over here and type onedrive.com, what server do you think I am on? Look at your notes and tell me. What server do you? I'm not logged in. I'm not looking at my cloud storage files. I'm just looking at the website only here. Web server, most probably what happened? Most probably I'm on their web server right now where they simply share the website files with me. Everybody okay with this? So sometimes guys, you're being moved from server to server, okay, where you have a server built for a dedicated function, okay, like a server built solely for handling printing, a server built solely for handling website requests, okay, right. Then guys, girls, you all saw the diagram over here. Now here you all see only one server now. Typically in today's world, it's many servers, not one server. It's many servers that you are connected to. And then we went through the benefits of it, we went through the drawbacks of it, and that is where we stopped. Okay, right. Let's move down to the next one. Everybody, our next type of network model, our next network model is something called peer-to-peer. Okay, computers are simply connected to each other. Nobody is managing the network as such. Okay, the best example I can give is your house. Think about your house network, guys. All of you all are connected to the same router. So for sure there is a network. But is there anybody managing the network? There is no server managing the network as such. So your home network is most probably a peer-to-peer network. Devices are simply connected to each other. That's all. Are we all okay with this? Can you guys read it now? Okay. This type of network can be as simple as one device connected to another. For example, a mobile phone connected to a computer. You call this peer-to-peer. They both have equal rights. Okay. A peer-to-peer network does not have a controlling computer managing the network. Each peer, each computer in the network has the same level of importance as the other devices. Devices are simply connected to each other. So normally, why would you create a peer-to-peer network? Can you guys read the last paragraph? Solely for devices to share data with each other, communicate with each other. Are we okay with this? Your reason behind creating a peer-to-peer network will be solely to exchange data. Are we good? Okay, right. Can you guys read your benefits? What do you mean by cost effective? Cost effective because there is no server, right? You are not purchasing a server here. Okay, the server is a massive cost. So in peer-to-peer, there is no server involved. Devices are simply connected to each other. All you need is a switch or a router. Everybody okay with this? A switch or a router is so much more cheaper than a server. Very much cheaper. Okay, right. Number two, easy setup. Everybody, that's why you all have it at home, right? It wasn't difficult to set it up. You guys can set it up on your own. Okay, you just simply connect all the devices to the same router or the same switch. Resource sharing, what do you mean by that? Can you guys read that? What do you mean by resource sharing? Think about it. In your house, how many internet connections are being shared? In your house, most probably it's one internet connection shared with the whole house, isn't it? Or maybe you all have got two routers, two different internet connections, maybe. But generally speaking, it's one internet connection that you're sharing with everybody, isn't it? Okay, then if you take officers, guys, they might share a printer with many employees. Instead of getting every employee one printer, they buy one printer, connect it to the network and share it with everybody. Okay, in a peer-to-peer network, you can do something called resource sharing. Could you do this in client to server also? Could you do resource sharing in client to server? Yes or no? Could you share resources in a client to server network? Yes, you can. Okay, this is a benefit that exists in both. In client to server also, you can share resources. In peer-to-peer also, you can share resources. Read the next one. Scalability. You can add devices, remove devices, not a problem. Okay. Reliability. If one device fails, the network will still keep running. Are we okay with this? Okay. If you think about your house also, just because one device isn't working doesn't mean the network goes down. Okay. The network will still run. What are your drawbacks, guys? Number one, since nobody is managing the network, you will have security issues. Okay, you're not managing the whole network from a central device, right? Okay, so installing an anti-malware or anti-adware, you'll have to do it device by device by device, you'll have to install it. From the server, you can't manage all devices. Are we good? Can you guys read that? There is no centralized control, makes it harder to secure data and monitor unauthorized access. Limited performance. Each device accesses both the client and the server, which can slow down performance where many requests occur. So when everybody is on the network, there can be severe congestions on the network. And you don't have a server to manage the traffic for you also. Okay. And number three, there is not poor backup, there is no backup. Everybody okay with this? In peer-to-peer, normally there is no backup. Devices are all connected to each other. There is no backup device or a server carrying out backup. Everybody is responsible for their own data. Are we okay with this? In a peer-to-peer network, you are responsible for backing up your data. There is no server that will take care of it. Am I okay with me? Okay, you guys saw it now? So we have two network models we have gone through, client to server, peer-to-peer. You guys have used both. I mean, all four that we are going to learn today, you guys have all used it. Let's see the third one. Everybody, shall we come down to the third one? Are there some more disadvantages? Difficult administration. Okay. And the last one is less efficient for large networks. Okay, boys, is all of you loyal with me? Okay, what's going on over there? You on the cover page still? Okay, right. Everybody, can you go through this? Drawback number 4, drawback number 5. Okay, difficult administration. You can't manage. There's no server to manage your clients. We are on page number 7. Okay, and less efficient for large networks. Okay. Right. Everybody, are we okay with this? We now move on to the third one, ad hoc network. This is a network that is spontaneously created. You know what spontaneously created means? At the spur of that moment, you need to transfer data. How do we transfer data? You create a network on your own. You don't use an internet connection. Normally, how do we transfer files? Let's say, for example, you have a video you want to give me. What is the normal procedure we would go with? You have a video on your smartphone you want to share with me. What is your normal procedure? You would WhatsApp it to me. How does WhatsApp work? You're connected to an ISP. ISP is connected to the internet. Okay, you connect to WhatsApp server, send it to WhatsApp server, then WhatsApp server sends it to my phone. I download it, I watch it. There's a huge infrastructure involved, right? But let's say, for example, internet is not working. Now what do? You know what? It's on your smartphone, it's on my smartphone. Internet is not working. You don't have a SIM card, I don't have a SIM card, Wi-Fi is also not available. Now what would you do? Think and tell me. Bluetooth. You would set up maybe a Bluetooth connection. Everybody okay with this? When you create a network on your own without using standard equipment or without connecting to the internet, this is known as what we call a ad hoc network. Okay, with whatever is available, you try to exchange data. Is it clear? So there's no fixed structure. Everybody okay? Now in client to server, there is a fixed structure. There is a server, there are clients, they are connected to switches, switches are connected to routers. Is it clear? You have a structure. Peer-to-peer, you have a structure. Devices are all connected to a router. Devices are all connected to a switch. There is a standard structure. In ad hoc, there is no standard structure. Is it clear? Users create a network with whatever they have. So it might be a Bluetooth network, it might be an infrared network, it might be a network even where you're using a Type-C cable, a data cable to transfer data. Everybody okay with this? Right, can you guys read it now? Boys, all of you read it below. A network that has been set up spontaneously at the spur of the moment. At that moment, you needed it for a temporary period of time. Okay, keep reading it. It has the same structure. Devices can still communicate with each other. Devices can still exchange data with each other. There is no central point. There is no server in this. Okay, keep reading it. Ad hoc networks are normally set up to temporarily share resources such as files. Okay, everybody okay with this? Keep reading it. This type of network is often used when traditional normal network equipment is not available. You don't have routers, you don't have switches, there is no Wi-Fi, there is no SIM card, there is no mobile data. Now how do we transfer data? Okay, that is when you go for what we call an ad hoc network. You create it with whatever resources you have. There is no fixed structure as such. There is a long example over here, straight from the textbook I took it. You guys can just quickly go through it. So a group of students working together in a park. Each student in the group has a laptop and they now want to exchange files with each other. They don't have a router as such with each other. So a student sets up what we call an ad hoc network to connect their laptops. Okay, everybody. Everybody, can you go through it? So a student from his laptop, he sets up a network and opens the network for other devices to join. So when other devices join that laptop's network, now they can exchange files with each other. Everybody okay with this? Okay, this is what you call an ad hoc network. There are no routers involved, there is no switches involved, there is no ISP involved, there is no server involved. Okay, but at the spur of the moment, spontaneously, that was created. Once the students have finished their work session in the park, the network is dismantled, as in network is switched off. Okay. Can you guys come down to the benefits of an ad hoc network? This type of a network, boys, can be set up anywhere. Okay, you don't require specific networking equipment. You can set it up with whatever you have. Okay, it is cheap. Okay, but you have certain drawbacks, limitations. Can you guys go through the drawbacks? Security is going to be a major problem. There you wouldn't be having encryption and things like that. Okay. Then managing traffic can be very difficult. Okay. If the ad hoc network becomes too large, too many devices on it, all devices are communicating with every other device, you could have severe congestions on the network. And on top of that, you're not even using proper equipment. So then congestions can get really bad. Okay. And not all devices are able to connect to an ad hoc network. Everybody okay with this? Certain devices may not be able to connect to it. Are we good? So everybody, we have now seen the third type of a network. Okay, not the third type of a network, the third network model. Guys, last week also I asked you all, now last week we didn't have class, the week before that, networks can be categorized by their sizes. What were those sizes? A network around one person we were calling personal area network. A network accessible within a specific location, local area network. A network that you can access around the world, wide area network. Those were networks by their size. Now we are looking at networks by their model. How are they connected to each other? Okay, so we spoke about a client to server where devices are all connected to a server. That was non-client to server. Then we spoke about another one called peer-to-peer, where devices are simply connected to each other. Nobody is managing the network. Then we spoke about a third one, ad hoc, where there is no fixed structure. Okay, every time ad hoc network is created, the structure changes. Okay, right. Now we come down to the next one. Can everyone come to the fourth one? This also you have all used, isn't it? Tethering, we have all used it. Okay, right. Can you guys go through it? So don't go through it. Can you help us listen to me? Tethering is where you share a device's what? Internet connection with another device. Agree? So the device that's sharing its internet connection, we call it a host. A host device, such as in most cases, it is a smartphone, because smartphones support SIM card connectivity now. They have access to mobile data. They have access to mobile broadband. So in most cases, a smartphone will share its internet connection with another wireless device, like a laptop or a tab. Is it clear? How does the laptop or tab connect to this connection? Using Wi-Fi. Using Wi-Fi, can it also use a wired connection? It can. Using a Type-C cable, a data cable, it can. But normally we use wireless. Okay? Right. Can you guys now read tethering? Hold on again. One more question. The device that's sharing its internet connection can be called the host, or is called the host. There's another name also for it. The device that shares its internet connection is also known as the, if you switch on your data to be shared with me, your device would be known as the what? Hotspot. So you can call it the host and you can also call it the hotspot. Okay, right. Can you guys read it now? Tethering is the process of connecting another device to a mobile phone to make use of its internet connection. Whose internet connection? The mobile phone's internet connection. Tethering a device to a phone to use its internet connection turns the phone into a hotspot. The phone is also known as a host. It is also known as the hotspot. A hotspot can be considered as a portable router. Do you all agree with that? Your hotspot, now your phone basically is behaving like a router. Data packets are coming to your phone and then your phone has to decide where to send these data packets. Everybody okay with this? Okay. So what would you immediately notice when you switch on hotspot? How is your battery life going to be? Your battery life is going to start dropping very fast. Your phone would start heating up because your device is now working as a router. And if there are many devices connected to your phone, you would notice it starts dropping very fast. Okay, right. Can you guys read the next one? Tethering, everybody online. Tethering is mostly done using Wi-Fi. But that's not the only way. You can also use a wired connection via your data cable, via your USB port, your Type-C port. Okay, or you can even use Bluetooth, but you wouldn't. Why wouldn't you? Why wouldn't you? You can use Bluetooth, but I don't think any of you all have ever used Bluetooth. I have never used Bluetooth. Because slow meaning it has a low bandwidth, right? Bluetooth's bandwidth is low. Anything else you would like to add to it? Distance, poor range. Anything else you would like to add to it? Bandwidth is low. Distance, range is low. Another problem with using Bluetooth, how about its security? Its security is also very poor, isn't it? Bluetooth security is also very poor. So you wouldn't be using Bluetooth. Okay, right. Keep reading it, guys. So while traveling, you might connect to your smartphone's internet connection. Okay. So what are your benefits of tethering, guys? Any device, any wireless device can be given an internet connection even when Wi-Fi is not available, because your smartphone is getting its signals from a SIM card. Okay, I keep reading it. Tethering means that multiple data plans are not needed for each device a user has. Everybody okay with that? So for example, I have a smartphone and a tab. I don't get two separate SIM cards for them. No. Whenever I want my tab to access the internet, I just switch on tethering in my smartphone. I have one data plan. I share that data plan with my tab as well. But have you guys seen some SIM cards? They offer unlimited data, right? If you go through their terms and conditions, sometimes they have mentioned what? If you switch on tethering, it's limited to 20 GB or something like that. Everybody okay with it? Some data plans, they have a condition. If you switch on tethering, then it is limited to whatever amount. They give you an amount. Okay. Right. Can you guys read the next one? Tethering can be more secure than a public Wi-Fi connection. How is that possible? How can tethering be more secure than a public Wi-Fi network? How can tethering be more secure than a coffee shop's Wi-Fi or a airport Wi-Fi or a McDonald's Wi-Fi? How is it, guys? Both have passwords. Coffee shop also provides you with a password. When you buy an item on the bill, they might mention the password. Airport also, they might give you a code. It's valid for 30 minutes. What did you say? It's private means. I can't see who's saying the answer. You said that. What did you say? In a public network also you can block. No. Airport also you can. So airport, what do? They give you a code. They give a username and a code, and the Wi-Fi works only for 30 minutes. If you want to renew it, again, you have to go to that self kiosk and renew it. So public versus private, what does that mean? Enough. Now you're getting there. Other people can access. So exactly. In a public network, you do not know who else is on the network. What are they doing on that network? Everybody okay with this? When you join a public network, you do not know who else is on that network and what are they doing on that network. Is it clear? Everyone okay with this? But in a private network, you know who else is on the network. So when you switch on tethering, guys, you know who is connected to it. You know it's your devices only. So it's much more secure. In a public network like a coffee shop, airport, McDonald's, you do not know who else is on that network. Okay, so it's not secure. Okay, can you guys go through it? Tethering can be more secure because it's a private network. You know who is on that network. Okay, right. Can you guys go through the drawbacks of it then? What are your major problems with it? So number one, it can drain the battery of the device. Okay, it can also heat up the device. The device can, start to feel quite warm. Okay, then your data plan is going to be consumed quite quickly because another device is using it. And normally, guys, on all our devices, what's the setting? Update on Wi-Fi, isn't it? Normally, our laptop and our tab, we have said update when connected to Wi-Fi. So when it connects to your hotspot, it's through Wi-Fi now. So what does it start doing? It starts doing a lot of updates in the background. You get it? When your tab connects to your mobile phone hotspot, it's through Wi-Fi now. It doesn't know it's a hotspot. It's a Wi-Fi connection for the tab. The tab will start carrying out many updates. Okay, and then what's going to happen? Your data quota is going to be used up very quickly here. Okay. Sometimes, guys, you all share, you all switch on hotspot for your friends to connect to, for your friends' smartphones to connect. In your friend's smartphone, what's the setting? Update on Wi-Fi. So when they connect, without them realizing, so many updates are running in the background. And whose data quota is being used? Your data quota is being used. Okay, right, keep reading it, guys. Streaming videos or downloading large files like updates could use up a lot of data allowance in the data plan in a short period of time. What about your bandwidth, guys? We didn't mention that. The host device's bandwidth is now going to be shared, right? The host device's bandwidth is now going to be shared among multiple devices. Okay, can we just quickly note that also down? I haven't mentioned it here. The host device's bandwidth will be shared among all connected devices, will be shared among all connected devices. The host device's bandwidth okay. So another problem you have is your bandwidth is going to reduce because you're sharing it with all connected devices, right? I'm going to move away from here then. Okay, everyone. Let's move away from here. So we have seen 4 network models: client to server, peer-to-peer, ad hoc, and tethering. Okay, we have seen 4 network models. Okay, right. We're going to move down now. Everybody, now we come down to network metrics. Okay, this is our last part for part 2. Everyone, can you come down to network metrics? So guys, network metrics are numbers that will tell you the situation of your network. Everybody okay with this? Just like how at the end of every term we give you all report cards with numbers indicating your performance in every subject. Just like that, when you run a network, we will be giving you numbers, or the network will generate numbers to tell you the situation of the network. Now these words are going to get a bit confusing. So I have taken down some examples to show you all that will make it a bit easier for you all to understand. Okay, right. Can you guys read the first one? The first metric is something which we call speed. Can everyone go through speed? And give me a second to see if I noted it down. Can you guys read it? Give me a second to note down. I did not take it down. But doesn't matter. Can you guys read it? Okay, one of the most used network metrics, the network speed, is simply the speed at which data is transferred. Okay, how much of data is being transferred every second? It is usually measured in bits per second. Do you all agree with that? I took this from the textbook. Do we normally measure using bits per? What do we normally use? No, megabits per second, right? Can you just put that unit there? Okay, normally we use megabits per second. Okay, Mbps. Okay. Right. So speed is how fast is data being transferred, or how much of data is being transferred every second. That is your speed. Right now, if you check the way your data is flowing, that is your speed. Everybody okay with this? For example, guys, if you stand on the highway and vehicles are moving, this, I'm going to say speed. They are moving at a certain speed. Everybody okay with this? They are moving at a certain speed. What they are doing right now is their speed. Everyone okay with this? Whatever they are doing right now is their speed. That keeps changing. Are we okay with this? Read the next word now, bandwidth. Everyone read bandwidth. The maximum amount of data that can be transferred from one device to another in a set amount of time. Everybody okay with this? Don't think about computers. Think about the highway below. On the highway, depending on the size of the highway, depending on the width of every lane, the highway will have a maximum speed, right? The maximum that vehicles can travel on this highway, they would have a value, right? That maximum speed is what we call the bandwidth. Everybody okay with this? So when you subscribe with Dialog and SLT and all, when you subscribe with ISPs, they give you their bandwidth. This is the maximum that we can transfer data for you. Is it always going to be at that maximum value? It's not always going to be at that maximum value. There'll be various factors that affect the bandwidth. Go ahead, tell me. What are the factors that affect your bandwidth? Okay, wait 1 second. Blockage, physical blockages, right? Something else? The device that you're using may not support the bandwidth that the ISP is offering. ISP is offering 1 Gbps, but your device network interface card doesn't support that speed. Your network, 1 second, your network interface card supports, for example, 100 Mbps only. So there's a big drop in the speed. Like you said, distance, okay? Distance also matters, okay? Something else? Transfer method, wired or wireless matters. Something else? If it's wireless, in this room, you also have other wireless signals. What do we call that? Interference can also reduce your speed. Okay, so guys, can you all read bandwidth now? The maximum amount. Okay, that is your bandwidth. Again, guys, we have a problem over there. If you go and check SLT, if you go and check Dialog, guys, they don't mention the bandwidth in bytes or bits. They mention it in megabits. I think SLT in fiber optic, they mention it in gigabits per second. They say 1 gigabit per second. Okay, so if you all can correct that over there. Okay, everybody over here, it's typically Mbps. The maximum amount of data that can be transferred from one device to another in a set amount of time. Okay, that's your bandwidth. Keep reading it, guys. For example, a network that has a bandwidth of 50 megabits per second can transfer up to 50 million bits of data per second. That's the maximum. Everybody okay with this? When you buy network equipment, they will mention the bandwidth. This particular equipment can support such a bandwidth. This is the maximum it can support. Are we okay with this? Okay, boys, all of you. Read the next paragraph. A higher bandwidth means it can support faster speeds. Okay. The available bandwidth of a network is shared between the devices that are a part of the network. Okay. This means that nobody mentioned this factor now. Your bandwidth can also reduce when the number of users, devices, applications, programs increase. Okay. All right. Then guys, the third one, to add to your confusion, throughput. What is throughput all about? Can anyone differentiate between bandwidth? You all understood now? Between speed and throughput, how will you differentiate it? What do you think? Sounds very similar, right? Actual amount. Speed is your? Approximate. Very good. Very close. Anything else you'd like to tell me? What am I seeing right now? Not bandwidth. I'm seeing my speed. I'm viewing my speed. It keeps changing. Depending on various factors, it keeps changing. Okay, I'm viewing my speed. Now, at the end of it, it does a calculation. So much of data was transmitted in so many seconds. And now it gives me a value. This value is my throughput. Everybody okay with this? Your throughput is normally derived after data has been transferred. After data has been transferred, you take your file size, you take your time taken, you divide the two, and you come up with a value. No, that's your throughput. Everybody okay with this? Right now, what's happening? That's your speed. Right now, what is it doing? It's your speed. At the end, the speed keeps changing. At the end, you take your, what do you call, file size divided by the time. The value that you get is this is the actual speed. Okay, like I said, average speed. This is your throughput. Everybody okay with this? Okay. So can you guys go through this? The bandwidth is your maximum. How much can it accommodate? What is the maximum it can do? Your speed is right now, what is it doing? And your throughput is after your data has been transferred, you do your calculations and you get a value now. That is your throughput. Okay. Everybody okay with this? So we have seen 3 network metrics. So when you're purchasing network equipment, what do you look at? When you're purchasing, you're setting up your house network. Okay. You're setting up an office network. What do you look at? When you're setting up, when you're buying device, when you're buying switches and routers and we are deciding on your ISP, you will look at bandwidth. What is the maximum they can offer? Okay. Then when the network is running, you look at speed. When the network is running, when it's operating, you look at speed. Okay. And then at the end of the day, you might look at the throughput. What has the average speed been? What has the average speed been like? That is your throughput. Everybody okay with this? After you download your movie, you might get a value now of how long it took. That would be your throughput. Okay. How long is time? I'm not talking about how long. I'm talking about how fast. That is your throughput. Okay. Are we okay with these 3 metrics, boys? I think all of you are with me. Okay. These are, so far we have gone through 3 network metrics. Okay. Let's go through the 4th one. Okay. Scalability. We already know what scalability is. Okay. Can you increase and decrease it without affecting the network's performance? Can you all read it now, everyone? That's what scalability is all about. A network's ability to be able to handle a larger volume that it a network's ability to handle a larger volume of data than it normally handles. Everybody okay with it? There are certain networks, it can handle more than what it was built for. This is scalable. And there are certain networks, it's already working at its maximum capacity here. Cannot handle anymore. Okay, everybody. Okay. Can you guys read this? One way that a network can be made scalable is by being able to increase its bandwidth when necessary. Can you guys read that example? For example, a company decides to have a crazy online sale. Okay, sometimes their sale cannot handle the traffic. Their network is not capable to handle this massive traffic that is coming in. Okay, so the entire sale goes as a failure. Okay. Now, for example, guys, everyone, I'll give you all a real life example. When Platinum first started, we took 2 floors. We took the 2nd floor and the 3rd floor. When we started, we had 2nd floor, 3rd floor. For us to increase our classes, it was okay. We could manage. We had enough space to handle the increase in number of students. But after a certain point, we couldn't handle any more students. So we had to take 1 more floor. Luckily, this floor was vacant. Nobody was occupying it. We were able to take it. Then again, when the numbers increased, again, we were running out of space. We couldn't handle any more students. We couldn't scale anymore. We couldn't increase anymore. And then after some time, the 4th floor, there was an office there. They were going to move out. So then when we opened up that, we could now scale to handle even more students. The same applies in a network. Can your network handle a larger number of users? Is it able to work? Okay. Right. Everyone, are we okay with scalability? Okay. Right. Shall we move down to the next one? The next one, a word that we are all very familiar with, something called latency. How long does it take for data to return back to you? Your request, how long does it take for your request to be fulfilled? And latency is not always the same. Everybody, don't even read. Look at me and tell me, what do you think? What is the unit of latency? Milliseconds. Okay, everyone agree with him? We use milliseconds, but sometimes it can be so slow that you measure it in seconds. And I don't think you guys will ever have this problem where you may have to measure it in minutes. Okay, mostly worst case it goes into seconds. I don't think it has ever gone into minutes. Okay, right. Can you guys read latency now? The delay in the transmission of data across the network. Everyone okay with this? The delay in the transmission of data across the network. Okay, or you can say the delay in fulfilling your requests. You have told Ickman to load, Ickman is taking very long to load. You have clicked on place order, it's taking very long to place your order. You get it? Okay, this is what we call latency. How long is it taking to fulfill your request? Okay, right. Latency is measured using the time taken for data to make a round trip in the network. You know what that means, no? What does round trip mean? The time taken to send the request and for the request to return back. That's what they call a round trip. Keep reading it. For example, if a user sends a request to a web server for a web page, the web page is then returned to the user. The time taken between sending the request and receiving the web page is your latency here. Typically, what do we target for? Low or high latency here? We want low latency. We want latency to be really, really low. Okay? Guys, is latency always going to be the same? No, latency will vary depending on various factors. Obvious factors will be number of users on the server. When you have a huge number of users on the server, latency is going to be very high. Are we all okay with this? Okay. Right. Everyone, shall we read the next metric then? Shall we have a look at the next metric? Error rate. What is error rate all about? Look, we are saying rate. Rate is a percentage, right? When I say rate, I'm talking about a percentage. So what am I talking about? Can you guys read it? By the way, how does data travel in a network? In the form of packets. Everyone agree with that, no? Data travels in the form of packets. So when I send you a video, that video is broken into a million or billion packets. Now with that information, read this. A measure of the number of errors that occur in a network. It is usually measured as a percentage. Okay. The types of errors measured include data packet loss, data packet corruption, and data collisions. Okay, everybody? Right. A network with a high error rate can cause problems, as each packet that does not arrive correctly will need to be resent. Everybody okay with this? So guys, do you all know what's the formula for error rate? The formula for error rate is what was it? Number of error packets. Number of error packets. You all tell me below. Divided by number of packets. Total number of packets, shall I say? Divided by the total number of packets. Yeah. You're going to get a decimal number here. No? So what do you do to get a rate? Times 100. 100%. Everybody, this is your formula for error rate. Number of error packets divided by the total number of packets transferred multiplied by 100%. Okay. So this will be your error rate. And typically, guys, in a normal network, it should be less than 10%. Okay, it should be less than 10%. But if it is more than 10%, something is wrong in the network. Okay, something is significantly wrong in the network. Because whenever there is an error, data packets need to be sent again. Okay, so users are going to have to wait. Latency is going to increase. Okay. Then we have another problem, another metric. we have another metric, another one called packet loss. Okay, the name itself tells you how many packets never reached the user. Why will packets not reach the user? Why would data packets not reach a user? All of you? Data packets, sometimes when traffic is very high, congestions are very high, then what happens? Packets after some time lose their way. They give up trying to reach the user, or on the way they get corrupted, receiver's IP address gets corrupted, they do not know where to go. Everybody okay with this? So normally in networks that are extremely congested, what do you call? Packet loss is very high. Okay, typically in a network where, what do you call? Congestions are very high, too many users in the network. Okay, then packet loss starts taking place. You don't receive data that you requested for. Have you guys seen this problem happening? Sometimes you try to access everybody. The best example I can give you all is, for example, let's say election night. Election night, what happens? When you try to access Daily Mirror, what happens? This web page took too long to load. Daily Mirror doesn't load. It says loading, 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 loading. After some time, you get a message saying, but this web page took too long to load. Or you couldn't access the web page. Meaning data packets were lost. We couldn't find these data packets. It took so long, we gave up looking for them. You get my point? Okay, this is what you call packet loss. Can you guys read it now? A type of error that can occur in a network. It is a measure of the percentage of transmitted packets that were not received at the receiving device. Packet loss is also normally measured as a percentage. A packet loss of just 1% can significantly affect the performance of a network. Everybody okay with this? Okay. So what do you think the formula of packet loss will be here? Anyone, can you think the formula for packet loss? How do you know packets lost? So it will be total packets received, total PKTS received minus what? No, it will give us a negative number now. Other way, no? Give me a second. Total packets sent minus total packets received. It should be the other way, no? Everybody, total packets sent minus total packets received. Okay? Total packets sent minus total packets received divided by total packets sent. You're going to get a decimal number here multiplied by 100%. Total packets sent minus total packets received divided by the total packets sent. So this is another metric that you will use to check how many packets are being lost in your network. So when this number is high, when this rate is high, you know your network is having severe congestions. Okay, that's why packets are getting lost. Okay. Are we good? Then guys, girls, we're going to move on to the next one. Next, we have something called availability. Okay, availability, it tells you its meaning. Okay, how long is the system up? Or again, this is also taken as a percentage. Okay, how long is the system up and running? Okay, a measure of the amount of time a network is available for use. Have you guys sometimes got messages? I don't think if you are using online banking, sometimes we get messages. They say what? Dear customer, today from this time to this time, the system will be down for maintenance. Everybody okay with this? Okay, so normally when you're checking the performance of online banking in various banks, we check their availability. Okay, how long have they been up and running without getting disrupted? Everybody okay with this? Okay, can you guys read this? It is calculated as the percentage of time a network is actually available out of the total time it should have been available. Everybody okay with this? For the last so many years it has been running. Okay, you see, for those last so many years, how long has it actually been working and accessible? That's your availability. And for availability, guys, we look for a high number or a low number. Now packet loss, we look for a low number. Error rate, we look for a low number. Availability, you need a very high number, 99%. Okay, right. Can you guys read the reasons that can affect availability? Everybody, can we go through the reasons that affect availability? A measure of the amount of time a network is actually available for use. Okay, right. Keep reading it, guys. It is calculated. No. Wrong paragraph. Yeah. Can you guys see the reasons? Due to power outages, due to hardware issues, or downtime to update the network. Many networks have this problem. They go down for maintenance purposes. Maintenance means they have updates to install, they have a new feature to introduce. Okay. So network availability is measured as a percentage. Again, for availability, what will our formula be? Total uptime. Everybody, total uptime minus total downtime, not total uptime. Total operation, what do you say? Total, for as long as they have been operating, okay? Total operating time, I'll put OPR, total operating time minus their, I'll write it properly. Minus total downtime divided by total operating time. Multiplied by 100%. Are we good with this? Okay. And typically here we want a high number, unlike the others. And then finally, everybody, we have our final metric. Right, everybody, can we come down to the last one? Jitter, okay, a measure of the disruption that occurs when data is transmitted across a network. The number of, a measure of the disruption. I'll give you another definition also shortly. Can you guys read it? The disruption measured is often caused because of network traffic, network congestion. If data sent across a network gets disrupted because of latency or network errors, the network can start to lose data packets. The process of this disruption is the jitter of the network. Everybody okay with this? Jitter is caused because of severe congestions, a lot of network traffic. Okay, it can be because of many users or because a lot of data being transmitted. Okay, can you guys read the example I have given you all? Imagine, can you guys go through that? You're watching a video online. If all the data packets arrive smoothly, the video plays without issues, very smoothly it plays. It doesn't lag, it doesn't get stuck, it doesn't get what you call distorted. Okay, but if packets come unevenly, okay, some come late, some come early, because guys, when packets come to your computer, after what needs to be done? They need to be packets. Do they travel in order? Packets do not travel in order. When you send data to somebody, that data is broken into packets? No, each packet takes a different route. Are we all okay with this? Each data packet takes a different route. So when packets reach their destination, they all reach at different times. So guys, data packets after they reach a destination, they have to be put in order. They have to be reassembled. And then the video starts playing for you. That reassembling can take time. That is what we call our jitter. Data packets are all coming at different times. And now it takes time to reassemble them, put them together, and then start playing the video for you. Everybody okay with this? Okay, so that's what we call jitter. It's taking long to reassemble these data packets because they are all arriving at different times in a different order. Okay, can you guys keep reading it? So when jitter is high, what happens? The video might freeze, stutter, lose quality, get distorted, appear blurry. Okay, that uneven timing is what we call jitter. Your data packets are all appearing in at different times. Are we all okay with this? So then guys, girls, with that, we have then come to the end of part 2. Okay, I didn't think I would finish this so fast. Okay, right, doesn't matter. Everybody, we have some questions over here. Let me tell you all the numbers. The completed local area network uses a client server network model with 6 PCs connected to a server via a switch. Identify the statement that only applies to a client server network model. What do you guys think? A network of computers where services must be requested from an ISP. True? In client to server model, is there a, what do you call, is it mandatory for ISPs to be involved? There isn't, right? So A doesn't sound okay. What about B? A network of computers where any computer can provide services to any other computer. That sounds like peer-to-peer to me, okay? A network of computers where services must be requested from one computer. That sounds pretty good. That one computer is a server, right? Okay, what about D? A network of computers where all services are provided over the internet. Client to server doesn't mean internet is there. You can have a client to server network without the internet also. So from these 4, C sounds the best. So we go with C. Okay. Right, everybody, question number 2. Describe one difference between bandwidth and speed. What do you think about this? Bandwidth is the maximum amount of data that can be transferred in a network in a given period of time. Okay, while speed is what? The current rate that data is being transferred at, isn't it? We got a message which says, can you send me this tute? Okay, can you guys get down your answers, everybody? Everybody get down your answers, Willow. So bandwidth is your maximum. Okay, so you can say over here, bandwidth is the maximum, boys, is the maximum amount of data that can be transferred in a specified or in a specific or in a set period of time. In a set period of time. While speed is a measure of how much data is being transferred every of how much data, while speed is a measure of how much data is being transferred within a set period of time right now. While speed is a measure of how much of data is being transferred right now. Okay. Are we okay with this? Bandwidth is the maximum, speed is right now what's happening, and throughput is the actual amount. After everything has been transferred, you take your file size, you divide it by the time taken. That is your throughput. Okay, right. Then everybody, we have a major essay type question coming up. Okay, can we have a look at that? So I'm going to get back to my this thing now. Everyone took this down now? Boys behind, Adil, all of y'all okay there? I'm closing this and I'm going to come over here. And we are going to open this up. Okay, so everybody look over here. I'm going to move down to okay, question number 3, guys. Question number 3, they're giving you 6 marks. Can we pick about 3 metrics? Okay, can we first decide the metrics that we're going to talk about? Discuss how network metrics could be used to evaluate this network. There is a scenario, I haven't given you all that scenario, but you all can understand the question, right? So can you guys pick a few metrics? Tell me a few metrics that can be used to evaluate the performance of a network. Okay, let me give you all a start. You can say evaluating the performance of a network can be done using various metrics, boys, like speed. Next, give me some metrics below. Jitter, bandwidth, error rate, and I didn't get you. What? Drop back. What's that? Latency. There are even more. Availability we didn't mention. Okay. Right. What were you trying to say? Packet loss. Okay. Okay. Right. Guys are giving us 6 marks now. We'll take 3 units, 3 metrics, and we'll talk about them. Okay. So normally I would do a mind map, but it's okay. We can go ahead. So guys, which one can you all talk about easily? Pick up metrics that you can easily talk about. Louder? Speed. Should I take bandwidth first? Bandwidth would be a bit easier, isn't it? Okay. And so we'll start off with bandwidth. The bandwidth defines, or you can say, the bandwidth of a network defines the maximum amount of data that can be transferred within the network in a given period of time. Okay, so tell me guys, high bandwidth or low bandwidth, what does it mean? You pick one side. A high bandwidth would mean that this network is capable of operating very smoothly, okay, responding to requests very quickly. Okay, you choose high bandwidth or low bandwidth. You go with high bandwidth. So a high bandwidth would mean that this network is operating very smoothly. Right. So a high bandwidth would mean that this network is operating very smoothly. What is the next unit we'll take? Girls, you all say something below. Which unit shall we take? You all mentioned you can take speed, you can take jitter, you can take bandwidth, error rate, latency. Which one? Latency. Okay, excellent. Okay, next. So Lihara, yes, what does latency define? Do you remember? Not Lihara, right? Okay, what does latency define? How fast, shall I say how long? How long it takes to fulfill a request on the network, isn't it? Or how long does it take for data to travel and return back to the user? It's a round trip, no? So an easy way you can say is next latency. Guys, if you all have space, can you all also mention the units that we use? The bandwidth of a network, which is measured typically in MB. I don't think you all have space, but if you all can put an arrow even and just mention this sentence, mention the units. Or if you want at the end, you can mention it. It is measured using Mbps. At the end, even if you want, you can mention it. It is measured using Mbps. Okay. We must also mention the unit now. Okay. Which is measured typically in Mbps. Next, latency, which is measured in milliseconds, ms, right? Which is measured in milliseconds. Okay, which is measured in milliseconds, defines how long, or shall I put milliseconds in full form? Milliseconds defines how long it takes for the network to fulfill a user's request. Okay. Now pick a side, high latency or low latency. A network with low latency shall we take? Means a network with low latency would indicate that due to various factors, like what can cause latency to be, no, a network with low latency, right, would indicate that user requests are being fulfilled in a short period of time. A network with low latency would indicate that user requests are being fulfilled within a very short period of time. Okay. Boys in the middle, what do you all think? Next metric. What shall we pick up? Kenneth, right? What do you think? We mentioned speed, we mentioned jitter, bandwidth, error rate, and latency. From that, we have taken bandwidth and error rate. Latency. Speed. Okay, we can take speed. Shall we take something that's completely different? Like maybe error rate? Okay, we'll take something that's, anyway, I asked you, right? I should take your answer, isn't it? Okay, we'll go with speed. Okay, how would you define speed? The metric speed tells us what? Tells us how fast data is being transferred at a given moment. Okay, the metric speed tells us how fast data is being transferred at a given moment. It is normally measured using Sorry, Mbps, megabits. It is normally measured in megabits per second. Let's take the opposite now. A low speed would mean that we always spoke about the good side. Now let's talk about the negative side. A low speed would indicate that it's taking long for data to be transmitted across the network. Okay. Everyone, give me 1 second. I'll take attendance quickly. One second, please. Boys over there, all done? Come on, finish our first. Okay, then guys, we're going to move back to part 1. We have a few questions in part 1 I want to do. Okay, right, everyone. I'm closing this then. Okay, I'm closing this. We are done with part 2 past paper questions. Okay, right. Everybody, can you have a look at part 1 then? In part 1, can you have a look at question numbers 2 and 4? In part 1, question number 2 and question number 4. Oh, we are done question 2, right? Sorry. Everybody, part 1 is also done, no? I'm playing the wrong one. Topic 1, part 3. Topic 1, part 3, question 2 and question 4. Topic 1, part 3. Topic 1, part 3, question 2 and question 4. Boys, everyone over here. Come on, guys. Page number on topic 1, part 3, page number 11. We are on question number 2. One role of an operating system is to manage your device's security. Okay. Explain one way in which an operating system could manage security in the school's network. What security feature can an operating system have that can manage security in a school network? Everybody? Antivirus could be said. What software is used to prevent unauthorized users from accessing your device? Firewall. And do operating systems have firewall? Yes, they normally all of them have firewall. Shall we write firewall over here? Because you're talking about a network now. Okay. So everyone over here, you can mention using the firewall of the operating system, unauthorized access to the school network or its devices on the network can be prevented. Using the firewall of the operating system, unauthorized access to the school network or its devices on the network can be prevented. Right, everybody, we are going to move down. Everyone, we are moving down. Right, you have taken this now? Right, everybody, let's have a look at question number 3. An operating system is a software application. Okay, describe the role of the operating system in managing a peripheral device. Everyone, do we know what peripheral devices are? All your, what are peripheral devices? Devices that are connected to a computer. Can you break it into various categories? Input, output, storage. You can break it into various categories. So what does your operating system do when it comes to dealing with peripheral devices? Configures it, install drivers, or it communicates with the drivers in order to work effectively with the peripheral devices. Isn't it? Everyone remember what drivers are? Drivers are basically a small software that tells your operating system how to work with a particular hardware device, isn't it? When you install this webcam to your laptop doesn't know how to work with this webcam. This webcam's drivers have to be installed. When the drivers are installed, now this laptop knows how to work with the webcam. Is it clear? So managing these drivers, whose duty is it? It is the duty of your operating system. Everyone, I feel like you are not with me. Everyone, you can say the operating system is responsible for providing a platform for device drivers to be installed, and then through each device's driver, the OS will be able to manage each peripheral device. Okay? Avish, why aren't you writing? You didn't have the paper with you. Then why aren't you writing? Come on. Okay? Can you all stop for a second? Everyone, stop for a second, please. Look here. Through my operating system, I right click and I come to, where is it? Manage. Where is manage? Manage is here. Through my operating system, and then my operating system shows me, give me a second, it's loading. My operating system shows me something called device manager. Here it shows me all the peripheral devices connected to my laptop. And then can you all see when I click on a peripheral device, can you all see? Here you go, it is showing me the devices that are connected. And when I right click, can you all see? Update driver, uninstall the device. Is it clear? I'm managing my peripheral devices through the drivers. Okay, everyone? So can you guys get this down now? Talk to yourselves and take it down. The operating system gives a platform for the drivers to be installed on. And when the drivers are installed, the operating system will manage the hardware devices through the drivers. Okay. I don't have a proper example to show you all. Guys, not a good example, but something better than nothing. I want to increase the volume in my laptop. I have a speaker, I have a sound card now. I have a speaker. A speaker is a hardware device. Agree? A speaker is a hardware device. When I want to increase my volume, who do I tell it to? Huh? I tell my operating, sorry, I had like you said printer. That's why I was asking what. I tell my operating system. Everyone saw this? Look at the bottom. I tell my, I'll try it from here. I tell my operating system to increase the volume. Where is it? I tell my operating system, increase the volume, decrease the volume. Now my operating system through the drivers is telling my speaker increase or decrease. You get it? I tell the user tells the operating system through the driver, it will, or through the driver, through that tiny program, it will then inform the speaker to increase and decrease. Okay? Right. Then guys, what about the next one? Describe the role of the operating system in managing processors. Answer this question first. Where are processors done in your computer? CPU, very good. Where are processors done? Processing of data into information is done where? Is done in your CPU, or you can call it your processor. Okay, so tell me now. Guys, you'll answer the most important part. Now put it into words and tell me below. Processors are done in your CPU. Is your CPU smart enough to know what to take and what to? Your CPU doesn't know. Your CPU will take whatever it is given. Whatever it is told to process, it will process. Okay, it is not smart enough to decide what to process first, what to process second. Your processor doesn't know that. Okay, who remembers this? Sometimes, how can I tell it to you all without telling the answer? Sometimes certain processes need to be dealt with immediately, which we were calling. They were never a part of the plan of processors, but all of a sudden, they now need to be dealt with immediately. Like, for example, you get a phone call. It stops everything and puts the phone call in front. Oh, come on, guys. What were we calling this? Priority. So the phone call is top priority. So your processor deals with it first. Who decides the priority? So the OS, but what do we call this? Where suddenly your phone call got more priority than all the other activities. You're watching a movie, the movie stops and the phone call is put in front. The phone call request is serviced. Everybody? Inter what? Guys, if we learn something called interrupts, you all remember interrupts? Everybody, when you're talking about managing processors, we spoke about interrupts. Interrupts can take place. Who decides it's an interrupt or not? Your operating system. And how much of priority is going to be given to that interrupt? Operating system decides whether to stop everything and inform the user. You're taking a printout. Okay, and there is an error in the printer. There is no paper in the tray. That message needs to be brought forward to you immediately. Is it clear? It's a high priority error that you need to be informed about. Who decides whether to make it high priority or low priority? Your operating system. Anyway, that was a bit off the topic. Now answer this. Describe the role of the operating system in managing processors. What do we say over here? Processors are done in the CPU. Managing of the CPU is done by your operating system. So what does your operating system do with the CPU? What does your operating system do in terms of managing processors? So your OS will decide how much of time each process gets in the processor. You get it? And processors that the processor is not dealing with, where will they be brought to? Right now, Chrome is open, but I'm not dealing with Chrome right now. Where is it? Come on, A-level students. In the background, meaning who is holding it? In my RAM. Is it clear? Who took it and put it in the RAM? My operating system. Now, the moment I take Chrome up, everybody, the moment I bring Chrome up, who puts it into the processor, gets it processed and brings it in front for me? My operating system. Everybody okay with this? So how do we work this? It's a bit difficult. You can say you can say processing is done in the CPU. Managing the amount of time each process gets in. I didn't show it to you all now. Control Shift Escape. Look here, look here, look here, look here. Control Shift Escape. Read the headings here. Read the headings here. CPU. You know what CPU is now? CPU is my processor. These are my apps that are opened. Okay. What does it say over here? Background processors. Okay. Background processors. There are so many. Can you see? Most of them right now not being processed. Some of them getting very little amount of space in the processor. 0.1, 0.1 come down. There are some who might have more than that. 2.2% Windows audio device, whatever. I do not know many of these even. Okay, 1.8 WMI provider host. Then the operating system has certain processes that are still running. My desktop window manager gets so much of space or time in the processor, or get so much of attention from the processor. Who is managing this? My operating system. Are we good? Okay. Processing is done in the CPU. Managing the amount of time each process gets in the CPU is handled by the OS. Okay. I can also add one more thing. I also want to talk about the RAM. Processors running in the background will be moved to the RAM by the OS. I don't think we need to say this, but you all now understand what's happening. Processing is done in the CPU, but the CPU doesn't get to decide what to process. Operating system will tell it what to process. Okay. Okay. I think, come on guys, I'm running a bit out of time. Right, let's do one more. Okay, guys, girls, everybody moving down. Okay, so here it says guys, let's do the mind map for this film. Everyone, let's do the mind map for this. Next week when we meet up, we'll write our final answer. Everybody, let's do the mind map. All the strengths and weaknesses you all can think of. And then next week we'll do the mind. I'll take down the, where's the question? Essay answer. This one we wrote the final answer, right? Topic 1, part 1, there was essay question. We wrote, I remember, right? That baby's device or something. We did. Okay. Right, everybody, can you all read this question here? Everybody, today mind map. Next week we'll do the question. Afram runs an after-school center for students. The center has been given some PCs. The PCs do not have any operating systems or other software loaded. Okay, girls, all of you with me? Situation is, the scenario is clear, right? Afram has a limited budget. He plans to use open source software on the PCs so that students can use them to study and socialize. Okay, boys, can you all understand the situation here? There is no operating system or any software. Afram has a very small budget, limited budget. he wants to use open source so that students can study the source code. And also he mentioned socialize. We'll see what that means. Evaluate the suitability of open source software for this purpose. You guys know the purpose now. Your evaluation should include strengths and weaknesses of open source, possible alternatives other than open source, and what is your conclusion? What should be done? Okay, shall we get started? So everybody will start with strengths and weaknesses. This is a mind map, not your final answer. Note it down separately. Strengths and your weaknesses. Anyone like to start? You all know the scenario, no? He's on a limited budget. He wants students to study them. He wants them to socialize through the software. What do you all think? Yes, what shall I say for strength? Shall I say source code is provided so students can study the software? Source code provided. Source code provided. So students can study the software. Is that the only thing you can do when source code is provided? Edit as in modify according to their requirements. Further, can modify software according to requirements. You know what I mean here, right? This is only our mind map. Then next we can say, what else can I say? Can I say mostly financially free? Okay, supports his limited budget. Right. Next, what are some of the weaknesses you can tell me? Lack of security. Okay. Lack of security because? Oh, because source code, because of source code. Okay, because source code is available. Okay. Something else? How about help and support? Bad because it's open source. There is no dedicated customer care team and all. You get your support from the community, right? You have to ask your questions on forums. Okay, and then users from around the world will support you with answers that they think are right. Okay, you can say poor customer care and support, or you can say no customer support available. All right, something else? Guys, what else? Who are the testers of open source software? Everybody, in proprietary software, normally they have a group of developers who will test it and then release the product to you all. In open source, who is testing it? You guys are basically the testers. You all have to test it and then get back to them. You get it? Okay. No formal testing before software is launched. Basically, students will have to be, testing. Right. Next. Next, guys. Come on, I've said all the answers so far. What else would you all like to add? Guys, how does socializing happen through open source? How does socializing happen through open source? So generally, I told what was the other category? Open source focuses on releasing the source code. The other category was proprietary. Okay, the other one was where it's more about collaborative working, coming together as a community, working together, developing together. The software might be financially free. They focus on freedom. That was known as free software. Okay. So guys, in open source, is there any opportunity for socializing? What did I tell you? When you have a problem with your software, where do you get support from? You get support from the community, right? You have to go onto a forum and ask your questions and find answers on the forum. So in a forum, you start making friends, right? You start connecting with other developers. You start connecting with people who have similar problems as you. Is it clear? So you can say over here, communities exist to solve problems related to software. Okay, so what is the benefit of this? Can encourage students to socialize. Okay, I don't know how I'm going to put it in my final answer, but I'm just noting it down. Okay, communities exist online to solve problems related to software. Okay, anything else? Any weaknesses? Do you think open source will have the latest features as a proprietary software? Definitely no. Okay, may not have the latest features as proprietary software. Right. Guys, any alternatives you would suggest for him? Any alternatives? We could recommend proprietary, but why wouldn't you recommend it? Because of the cost. Okay, proprietary. So I'll not note that down. So we don't have an alternative for him. What's your conclusion going to be then? Your conclusion is going to be then to install this, right? Your conclusion will then be go ahead with open source software, and you have to mention why. You have to mention these strengths. Okay. Go ahead with open source. And then you have to support it with why. With these strengths. Okay. Right, guys, get down this mind map. When we meet next week, guys, next week is going to be a very complex class. We are going to be learning about how data is transferred between computers in detail. Okay, so there are some diagrams, complex diagrams on how this data goes through various layers when they get transmitted. So come ready for it. Okay, everybody, next Thursday is going to be a complex class. Okay, everyone. Guys, girls, all of you all, until we meet again next week, take care, stay safe. See you all tomorrow for your practicals. Okay.